Welcome to my channel. This is just a personal channel. I'm going to be doing probably theoretical computer science and some applied mathematics and pure math. Mostly applied math because that's most of the stuff I've done, like linear algebra and maybe some calculus based solutions to computing, but nothing more than that since I'm a computer science undergrad at the current moment. But what I am going to do today is I'm actually going to show you guys, and I have my iPad down here. I'm going to show you guys how to do a DFA into a regular expression using a GNFA. So in order to do that, you are going to try to, of course, get the DFA into a NFA, and then from a NFA into a GNFA. Now, sometimes you might have a DFA that is already pretty much an NFA, because I mean DFAs are a subsidiary of an NFA, so you don't need to, in some cases you don't even need to do anything special to turn it into an NFA. You can consider it to be an NFA quite immediately, because DFAs are technically special versions of NFAs, because every NFA has an equivalent DFA, but not every DFA has an equivalent NFA. So they are not it's not a by implication, so they don't go both ways, but NFAs definitely do have DFAs, since they are considered subsidiaries. So in this case, this DFA is probably a special version of the NFA that we would have, and that would be the exact same NFA that would represent this. So what we're going to do first is we're going to turn it into a GNFA, but I'm going to do is I'm going to draw this thing. I like to use this sort of graph. So I think it's RAR, yep, RR, RRB, and RAB. Now the reason why I'm doing this table and I like this tabulation method, because it was taught to me when I was in a formal languages and autonoma class. The reason why I do this method is because in a lot of books they teach you, they'll even show it, that it's RAB, RR, and then you'll see the asterisk, the star closure or Klein star. You'll see RAB, sorry, R, I already have, RB, yes, union with RAB. There we go. That's everything. Okay. So with this, it makes sense when you look at the formula if you've done it before. If you haven't, it doesn't make any sense, which is what I'm going to explain today. But you're just finding the relationships between each of your points, and then kind of so that when you do rip it out, you know how to repair it. That's all. So the RR is just a self cycle. RAR is just checking the relationship with something that's going into whatever you're trying to rip out. So if you have like some input, what happens when I rip out that, like what's the relationship between that initial state that I'm trying to rip out and the thing that's going into it. Now RB, which is on the right side of that repeat, is going to be the relationship of the thing that's coming out of your rip state. So like if you had that input, it goes over to some sort of state that you're ripping out, and then that goes over to a output state somewhere. That's a transition from the rip state. You're trying to see what is, if there is there any relationship between you're trying to see what RB is, and then the last state you see if there's any direct connections between A and B, which the rip state would be in the middle. It sounds confusing, but I'll explain it in a second, and I'll show you exactly what we're doing. I'll even highlight it and all that sort of stuff. So what we're going to do is we're going to make some lines here just for the sake of ease of use. Now I made a video on this earlier. I did it on a whiteboard, but I actually ended up not liking the quality of it. It just did not resonate very well with me, and like I didn't feel like I wasn't able to edit the video very much or anything like that. I kind of made it on a day that I had classes and other things like that, and I just felt like it didn't really benefit anyone. So what you can do now in these kinds of states is you're gonna have multiple things that you're gonna have to deal with here. You know that you have multiple final states. So what you need to do to turn this into a GNFA is you need to take this and you need to add a start state here, which has a lambda transition. And then every final state is gonna have lambda transitions to a new final state that you're gonna rip, which lambda transitions are also known as epsilon transitions. They just stand for the empty string. So you need this because you need to be able to rip everything out until you have just the start and the final. That's what you're trying to do. And it's easy to just set up your own start and your own final, and then rip everything else around it, then try to rip things around your final states because you can only have one final state since you're trying to get a regular expression along that singular transition, which you'll see towards the end. So we'll go ahead and just rip out like state 2 first, which in this case would be this one here. And what we're going to do is we're going to write down 2 for the rip, and then going into it, we notice that we have multiple things going in. We have 1 to 2 going in and nothing else, so just 1. But we do have something coming out of 2, which is 2 to 3 and nothing else. So 1, 2, and 3 is our first one. I don't see anything else going into 2 besides the self cycle, which is fine. That gets taken care of on its own. If you look at AR, we're looking at 1, 2, 2. So what I'm looking at here is I'm trying to see what the relationship is on this state there. So what we do is if you see 2 things on the same line like that, this is the same thing as writing A union B, and that's the way I'm going to write it inside of our table here. So for AR, we have A union B, and I'm not going to waste you guys' time here, so I'm going to try to go fast enough to do the problem, but slow enough to explain it. So RR, go ahead and each of them are kind of self-explanatory in which one you're going to look at. So this means the rip state in relationship to the rip state. So what is the relationship with itself? Well, it has a self cycle with A, because we can see it right there, A. So we choose A, and then we check what RB is. So now we're checking these 2 states. So from, sorry, I hit my mic, 2 to 3. So 2 to 3, we notice there's only 1 transition there, and that is B. And then we check if there's any relationship between these 2 states, which is 1 and 3. If there's any direct transitions, because sometimes there is, right? There might be some sort of transition going from 1 to 3, and you could very well have that in an NFA. You could have multiple transitions with other alphabets or other letters, strings that are in your alphabet that you would not that you need to take into account, because you're going to be ripping 2 out. So if there's some other relationship directly between them, you might need to update it in respect to the thing you're ripping out. So in this case, there is none. There's no relationship, so we just put null set. Null set just means there's no relationship. You can't write anything for that. So in this case, now what we're going to do is we're going to take this formula, which I don't like formulas too much because they become like rote memorization. I'm not very big on rote memorization, but I'm not going to disparage against it here. It's good. It's very good in this case. So it's easy to explain too. So RAR, we just write that in. So we have A union B. I'll put that in parentheses for ease of looking at. A. So remember there's an asterisk here, which the asterisk means 0 or more. So I could choose to not cycle, or I could choose to cycle, but in this case you could choose A as many times as you want, which makes sense because I could cycle 0 or more times. I don't have to cycle, but I can if I wanted to, as many times as I want. I could go up to a trillion, a billion, whatever. Well, I did trillion, then I went down to billion, but whatever, you know what I mean? It's just a large number. Excuse me. And so we have RRB, which in this case we have B, so we just write B. Then you're unioning with the null set. So the null set does nothing. It doesn't add anything there for you. So what you can do is you can turn this regular expression into A union B, A Klein star or star closure, followed by a B. So that is going to be the new transition between 1 and 3. So you look at your A to B, not whatever you're ripping out, because it doesn't make sense to look at it whatever you're ripping out anyways, because that is your rip state. So you can't put any relationships with the rip state because that's going to go gone. It's going to be bye-bye. So let's look at 1, 2, 3, and we have the regular expression A union B, A star B. So now what we're going to do is I'm actually going to rewrite this. I'm going to have to do this really quickly because I don't want to like waste anyone's time, but we'll do start. This goes into 1. There's a lambda expression. And then we're going to rip out 2, but I'm going to put the final state down here. Final circle, circle. This one goes here, lambda. Then there was a 3 down here, which also happened to be a state. I don't think there was a relationship from 1 to 3. Yeah, it was 3 to 1. That's what I thought. Because I was going to say we just did that and there was nothing. So A, this one has a relationship with lambda as well. This kind of looks kind of jank, but I will make sure it looks good later. So we're ripping out 2. So we're going to just we're going to have to make a new relationship between 1 and 3 because 2 is being ripped. I just realized 3 also goes into 2. That was my mistake. I missed that in the beginning, but we're going to fix that right now. I wholeheartedly am sorry. I, for some reason, thought that 2 was going, I don't know why, but you need to write that 3 in there as well. But I will update it, and fortunately, this is a good way to check things, and I'll put that in the video because it's just noticing things as you go along. So I'm going to circle again, 3 to 2. We do need to check that one. It's still 2, but the output state, because 3 is the only one, it's 3 to 3. So it's going to be some sort of self cycle if you look here, because we're going to be updating the transition 3 to 3, because not 2 3 but all going to 3, like heading over to it, because 2 has an output that goes to 3, but 3 also goes into 2. So we're going to need some sort of relationship that represents 3 going to 2 and then coming back to itself, which would then, when getting rid of 2, would become a self cycle. So we can go ahead and add that in there, which I'm going to do that in a second. What we're going to do is we're going to check AR. So from 3 to 2, we have B. And then if we go to R to R, it should be the same. So it's A. If we check out RRB, we see that it's going to be 2 to 3, which in this case is going to be B as well. And then we look AB. So we say 3 to 3. There's no self cycle because that would count as a self cycle. A to B is to itself. So let me just check again. So AR would be from 3 to 2. 3 to 2 is B. Self cycle with A, and then RB is also B. So now we have a new relationship here. We're going to write out the formula we had. We had B followed by an A star followed by another B, union with a null, which in this case becomes, like I said before, B A star B, because the null set doesn't do anything when you union with it. It doesn't benefit you in any way. Now I have the states when it gets ripped out. So let's go ahead and look at 1 to 3 first. So there was no relationship between 1 to 3, but there will be one now because we have to. And I'm actually going to circle it on the outside. That's going to be a lot better because it's a regular expression. So A union B, A star, and then followed by a B. And then there's some sort of self cycle happening with B, A star, followed by B. So we have 2 more states to rip out, one of them being a 3 and one of them being a 1. You can do either or if you want to, but it's best to just choose whatever you feel like. If you feel like one of them is going to be simpler than the other, then do that. So what I'm going to do is, I should have done this earlier, but I'm going to circle this and I'm going to turn this into, I think it highlighted the picture on accident. I didn't want to do that. I just want the table. We're going to, okay, do that and try to push it down here, because I need the table, and I'm actually going to mark these things. So I said we ripped, so we ripped out 2. Here we are going to be did I put ripped? Yeah, well, and we'll say ripped 3. Go ahead, rip out 3. I need to get rid of these things. We'll do that here just to, of course, reset it, because these are not going to be the same. So we're ripping out 3, so we know that we can write 3 immediately, but we need to check out the relationships, and we got to look at this one because this is our new one. I'm actually going to copy it over so that I'm going to zoom out a bit so it's easy to move, so that we can see the actual transitions in real time. That's what it looked like when we ripped out 2. Now this is what it's going to look like when we rip out 3. So we have several relationships here. Not including the self cycle, we only have one thing going into 3 and one thing coming out of 3. Actually, 2 things coming out of 3, sorry. So you have 1 going into 3, 3 goes back to 1, and then 3 also goes to the final state, F. So we have, write all your ins and all your outs. We only have 1 in, we have 2 outs. So 1 in being 1, one of the other ends being 1, and then one of the outs being your final state. Now, why am I rewriting 1? Well, because it's the only in state. If you had multiple in states and multiple out states, you're going to be basically combining all of those in states with, it's going to be like, I'll do this on the video on the iPad. If you had like one in state, we'll put this as in, and you had some sort of rip state and you had multiple outs like that, out, maybe 2 ins, you would have to have, actually, let's go ahead and erase this because I want to write these. this in would have to get matched with every out, and then this in would have to get matched with every out as well, to check all those relationships. So if you want to check how many transitions you're going to be doing, it's going to be your ins times your outs. So like if you have one in and two outs, you're going to have two like entries in your table. If you had two ins and three outs, you're going to have 6 entries, because it makes sense, because it's ins. Every single one of your ins is going to have to pair to every single one of your outs, and then if you have 2 of them, 2 times 3 is 6. I'm just saying that's a good way to check. So in this case, we have 2 outs and 1 in. 2 times 1 is 2, so therefore I have 2 entries in my table. It makes sense. So that's lined up. We're going to do first is we're going to check AR. AR is from 1 to 3. 1 to 3 has the transition from before. That was A union B, B star A. Or it's A star B. I think I had that backwards. Oh. That's okay. I'm glad I caught that immediately. A star, yes. A star B. Self cycle there, and then we check out R if there's any self relationship. There is a self relationship. It's one we found before. So this is B A star B. And then we check if there's a relationship between RB, which is 3 to 1. There is a relationship between 3 to 1, that's A. And then we check if there's any relationship between A and B itself. So 1 to 1, which would be a self cycle. There is no self cycle. So therefore that is a null. And so for 1 to 1, this becomes A union B, A star B, and then I'm going to put parentheses to kind of like separate it again, but we'll do B A B star. So another, you can choose that as many times as you want, concatenated with A, union, null set. Because, and I can mark these again, this is RAR, this is R, sorry, that's RAR, this like entire thing on. I'll actually mark it like this. RAR, RR, RAB, union. I know I'm like messing up my curly braces now, but it's okay. RAB. This is as long as you get the gist of what it's covering. So that's our formula there. And this RR is always a self cycle, so therefore it has the Klein star, or star closure is what some people call it. It means the same thing. So that's that. In this case, this is going to equal A union B A star B, B A star B star A union null set does nothing. So we're done with that one. And then we do 1 to F. So in this case, we're going to do AR, which is 1 to 3 again. So this gives us A union B, A star B, because it's the same relationship. R to R is the same relationship, B, A star B. RB is going to be the only different one. So from 3 to F, that gives us lambda. If I look over here, that is a lambda transition right there. And then we union that with AB, which in this case is from 1 to B, 1 to F. 1 to F does have a relationship. It's also a lambda. But lambda is an empty string, so it doesn't add anything, but I'm going to write it out anyways and then show you how to remove it, which is just by ignoring it. But it counts as a removal, though, because it doesn't add anything to it. I'm writing out 1 to F. So this line here is going to be the next one. So this is B followed by B, A star B. It's going to be pretty much the same one as above. So this one gets repeated 0 or more times, followed by a lambda union lambda, which these lambdas are empty strings, so they don't do anything for your expression. A union B followed by A star B, followed by B, A star B star, and then get rid of the lambdas. Because they're empty strings, you don't need to add them. They don't benefit you in any way. So what I'm going to do, is this going to be a decent highlight? Oh geez. Yeah, we'll try it with this one. So these are our, wow, that's like a really weird highlight. It's kind of got a lot. I'm gonna make it a bit, sorry, I'm gonna edit it just a bit just because its size is kind of too much. So this one and this one are the ones that are finished. It's an airbrush, which is a bit different from like a regular highlighter, but it works well to highlight. It's nice enough. So what we'll do is I'm actually going to show the state change. So that's what we had before. So what I'll say is I'll say something like this. I'll say before ripping 3 and then after ripping 3. And we're going to rip 3 out here. So what we're going to do is we're going to erase 3. All of it goes away. All relationships with 3 go away. So 3 to 1, 1 to 3, 3 to the final state, all of that stuff's gone. And then we repair what we've lost. So in this case, you have a 1 to 1, which then becomes a self cycle, which is, which I don't want to rewrite again. Hopefully this doesn't take the highlight with it. I actually need to be careful. This is going to be really weird. I knew that was going to happen. But I was able to grab it anyways, which is nice. And I think there was some extra stuff that got grabbed in there, and it was the 1. I'm actually going to have to go back twice. Hold up. I can grab this without it. It's going to pull the 1. And I think it grabbed something else, but that's okay. I'll ignore that for now. A union B was the thing inside here, and this was 1. So 1, A union B. And that's it. I didn't miss anything. That is perfectly fine. Nothing else was taken away. So that's good. Okay, and then I have to be careful with the other one as well. So this is lambda, but it changes because that's 1 to F. So from 1 to F, you have, we'll just copy this one as well. It makes things a lot easier when you can just copy and paste, which I need to, whoops, zoom out first so I can see where I'm transferring it to. Copy, there we go. I think it duplicated. It should have duplicated there. Oh, that's grouping. There we go. Sorry. That is a duplicate. So this one is now done, and I can. There's only one state to pull out, and that's 1. So we'll do that. I'll just copy over this graph again, and I'm actually going to zoom out. I have to zoom out again. Every single time I do this, I have to zoom out because it's not like Notability or anything else like that where you can whenever you scroll, it like moves the page with your wherever you're trying to move your duplicate, so you don't have to like move the page first then duplicate it and do all this like weird page manipulation. So I missed a few of the lines here, but that's okay. Those go right back in, and all of these can be easily erased, so I have no issue with that, which I'm going to do here. In the future, I'll probably make like stickers like with these tables so they're easier to do. But this is kind of like a live demo of like how to do it, so I'm not really too worried about. This is like what I would be doing if I was actually trying to solve this on my own, because it's really nice. These tables are really, really nice because it's really easy to just plug the things in and then build the string or the regex exactly how it looks. You don't have to like you won't miss anything because it's all right there in front of you. You just got to put it together. So in this case, the only thing to take out would be 1. So we take out 1. There's only 1 in and 1 out. So it's going to be S to F. And then we check what's AR. So from start to 1, we have a lambda. And then from R to R, which is 1 to 1, we have this. So what I'm going to do here is something I do sometimes in my examples. What I'll do is I'll label these because I'll label this S, and it's only a placeholder. I'm going to put it here in the same color, and I'll choose like a light purple looking thing. This one will also be a choice. I'll choose this as E. It's just a variable. I'm just using it because sometimes when you're writing out stuff in the table, it's like, look how long that regular expression is. It's super long. Don't want to rewrite it 100 times. So if I write S, I know what S is. If I write E, I know what E is. And so in this case, we're going to keep going, but R to B is from 1 to F, which is that one, which is E. So I write E there. And then from A to B, that is from S to F, there is nothing because S does not directly go to F yet, but we're going to do that now. We have S to F becomes, and then we look at what we have. We have a lambda followed by S, which now I'll write out what it is because I can, or actually just copy it over, but S is going to be our R to R, which is this self-cycling relationship, but it is going to become concatenated right there. And that is copied over exactly. I just want to make sure I wasn't missing any Klein stars or star closures. So that was our AR, and then we have, or that was our self cycle 1. So you have to, whenever you concatenate that, you have to be careful. So we have to put parentheses on the outside here, and then star that. So after that, we need to move on to E. So with E, we have A union B, followed by A star B, and then you follow this with B A star B star. So that's exactly how it looked right there with E. I didn't copy it because I want to make sure I got it exactly. So the Klein stars just remember 0 or 1 choices. So I could choose to cycle it or choose not to cycle it, followed by a union with the null set, which does nothing for us. And neither does the lambda. The lambda could go away as well. So we know that our new relationship is going to be parentheses, parentheses, A union B, A Klein star or star closure, B followed by B, A star, B, close that off, star, close that off, star again, A union B, followed by A star, B, B, A star, B, followed by another star. Now, there's a lot of star closures there. That is completely fine. Now what we need to do is we need to take this and see if I copy this over correctly. I ended up missing an entire, hold on. Let's see if I can grab this entire, there we go. Copy this over, move it up here, and then I'm gonna do a double move. This should be really easy moving it down here now. Cool. So what we're gonna do is this is no longer after ripping 3, this is gonna be after ripping 1. Or you know what we could say something like this. We could say before, like we did before ripping 1. That looks like horrible writing. Sorry about that, but it's fine. I'm just trying to show the before and after so that it's easily visible as to what we did at each step. This one is going to be after, so we'll say after ripping 1. And then we'll start removing things. So we'll remove 1 completely. So everything that has to do with 1 gets removed. So all of this, all ins and outs. And then I'm going to move this up here just for the sake of looking good. And then what we can do is, I'm going to do a straight line here to there. Makes things really easy. And then we have this final transition, which we said this was from S to F, and that's what we're putting in because that is our new transition. This is our repaired transition between everything, which I will copy, move down here, and then we'll take this, and I can actually condense it a bit just so it fits on the line well. Oh gosh. There we go. And that's your final transition, which we're not done yet. This is the GNFA. So we can say that the GNFA is now complete. So you don't have to write this, obviously, but I'm just writing this for the sake of, you know, you being able to see it. And then your regular expression would be R for whatever your language is, or whatever this language is A union B, A star, B, B, A star, followed by another B, star, followed by another star, A union B, A star, B, B, A star, B, followed by another star there, which looks like a crazy regular expression. It looks completely nonsensical, and it may be. I definitely would not want to generate strings just straight up from the regular expression because it looks really annoying to choose from, but that's okay. Don't worry if a lot of your strings become really non-coherent like this. They do. That's just some, especially when it looks really simple. You think like, oh, maybe there's 3 states. It won't be that bad. There's only a couple A's, couple B's, whatever. And then all of a sudden it turns into like this monster of a regular expression that is completely valid. It does happen. Sometimes you'll have really small regular expressions. Sometimes I've had times where it'll turn from like a 6-state NFA into a like it's a 6 state one, you'd think it'd be a massive regular expression, and like half the states end up being completely worthless. You can just erase them without even, you can rip them out without even need to remove anything because they won't have any out states. It'll just be all inputs, no outputs, and you can just completely rip those. And then you, it goes from like a really complicated looking regular expression to like nothing, like maybe like two or three letters. So anyways, that's the end of that. I'm going to end both videos now, but essentially that is how you do DFA to NFA to GNFA to regular expression. So not too bad, and this is the tabulation method. There's many other methods though.